Welcome back to 3D Decode. In this session, we're going to talk about the lube oil system, or LOS, as per API 614. The lube oil system is often called the lifeline of compressors, turbines, and pumps because it ensures the bearings and seals are always lubricated, cooled, and protected. Let's break it down. Governing standard. The primary standard here is API 614, which covers lubrication, shaft sealing, and control oil systems. It defines reservoir sizing, filter and cooler requirements, redundancy philosophy, and instrumentation. Functions of LOS. What exactly does the LOS do? It lubricates bearings, reducing friction. It cools bearings by carrying away heat. It supplies clean oil to seals, especially in wet seal applications. And it maintains stable pressure during operation. Main components of LOS. Now let's look at the key components. Oil reservoir, tank, stores the oil with at least 5 minutes residence time at normal flow as per API. Internally baffled to prevent foaming and vortex formation. Pumps, main pump, usually shaft-driven or electric. Auxiliary AC motor pump, standby. Emergency DC motor pump, protects the machine during a blackout. Coolers, shell and tube or plate type. Always provided as two 100% capacity units, one operating, one standby. Filters, duplex filters, meaning 2 units so one can remain in service while the other is cleaned. Typically 10 micron absolute rating. Pressure control valve, keeps constant oil pressure at the bearings. Instrumentation, pressure, temperature, flow, and level transmitters. Plus alarms and trips for low pressure or high temperature. Typical LOS flow sequence. How does oil flow through the system? 1. Oil is drawn from the reservoir by the pumps. 2. It passes through the cooler, where temperature is maintained around 40 to 50 degrees Celsius. 3. It then goes through the filters, removing fine particles. 4. Clean, cooled oil is delivered to the bearing housings and seals for lubrication and cooling. 5. Finally, the oil drains back to the reservoir, completing the circulation loop. Design requirements, API 614. API 614 has very specific design requirements. Reservoir residence time must be at least 5 minutes. Redundancy, N+1 philosophy for coolers, filters, and pumps. Maximum allowable bearing inlet temperature is 60 degrees Celsius. Cleanliness must meet NAS Class 6 or better. The DC emergency pump must be sized to protect the machine during coast down. Mini quiz. Quick quiz time. 1. Which API standard governs lube oil systems? 2. Why is the oil reservoir baffled internally? 3. What's the function of duplex filters? Why do we need an emergency DC oil pump? Practical task. Here's a task you can practice. Sketch a simplified LOS P&ID showing reservoir, pumps, main, auxiliary, emergency, 2 100% coolers, duplex filters, bearing supply line, and return to reservoir. If you can explain this flow path on a whiteboard during an interview, you'll definitely stand out. Interview Q&A. Here are some common interview-style questions. What is the function of a lube oil system? A. To lubricate, cool, and protect bearings and seals for reliable operation. Why are 2 oil coolers provided? A. For 100% redundancy, one operating, one standby. What is the purpose of duplex filters? To allow continuous operation while one filter is cleaned. Why is a DC emergency oil pump required? To protect bearings during power failure and coast down. What's the typical residence time of oil in the reservoir as per API 614? Minimum of 5 minutes. And that wraps up our session on the lube oil system, API 614. If you found this video useful, don't forget to like, share, and subscribe to 3D Decode for more engineering insights. See you in the next video.